Hi everyone. In the previous lecture, we have seen equation of line and problems on equation of line. Now today we are going to see distance of a point from a line. Distance of a point from a line. If we have a line, this line is R bar is equal to A bar plus lambda into B bar, and the point is given, the point P is here with position vector alpha bar. Then the perpendicular distance of this point from the line is this one, if foot of the perpendicular is M. Then this PM is the perpendicular distance of the line L, or line R bar is equal to A bar plus lambda into B bar. Now as the equation of this line is R bar is equal to A bar plus lambda into B bar, it means that to this line a parallel vector is B bar. See, this vector is B bar. This is the vector which is parallel to the given line, and this line passes through the point A with position vector A bar. Point A with position vector A bar. So this is point A with position vector A bar. If you join this PA, so here this PM is the perpendicular distance or the shortest distance between the line R bar is equal to A bar plus lambda into B bar and the point P with position vector alpha bar. So therefore the distance of a point P with position vector alpha bar from a line R bar is equal to A bar plus lambda into B bar is square root of alpha bar minus A bar bracket square minus, this is magnitude of alpha bar minus A bar bracket square minus alpha bar minus A bar, its dot with B bar divided by magnitude of vector B bracket square. So this is the formula which gives us the shortest distance or the perpendicular distance of the given point P with position vector alpha bar from the line R bar is equal to A bar plus lambda into B bar. Next, if we have two parallel lines, then the shortest distance between them that we have to see distance between parallel lines. See, we have two lines. This is line L1 and this is line L2. These two lines are parallel. Then the shortest distance between these two lines is nothing but this perpendicular distance. If the equation of this line is R bar is equal to A bar plus A1 bar plus lambda into B bar, and the equation of this line is R bar is equal to A2 bar plus lambda into B bar. Now as these two lines are parallel to each other, so the vector which is parallel to these two lines is same, that is B bar. So see, the distance between parallel lines R bar is equal to A1 bar plus lambda into B bar, and R bar is equal to A2 bar plus lambda into B bar is modulus of A2 bar minus A1 bar, its cross product with B cap modulus. See, as the equation of this line is R bar is equal to A1 bar plus lambda into B bar, so that line passes through the point A with position vector A1 bar, and the second line passes through the point whose position vector is A2 bar. So if this is line L1 or if this is line L1, you may consider, so it is B with A2 bar, and here this point is point A with A1 bar. If we join these two, this is AB bar, and if this is the foot of the perpendicular M, so BM is the shortest distance between these two lines, means BM is equal to modulus of A2 bar minus A1 bar cross B cap. So this is the distance between two parallel lines. Now we have seen distance of a point from a line, and then this distance between two parallel lines. Now let's see the examples. Find the length of the perpendicular from, first problem, find the length of the perpendicular from two minus 3 1 to the line x plus 1 divided by 2 is equal to y minus 3 divided by 3 is equal to z plus 1 divided by minus 1. Now see here, the equation of line is given in Cartesian form. Equation of line is given in Cartesian form, and the point P is also given in Cartesian form. Now you can convert this Cartesian equation into vector equation. As the coordinates of the point P are known, so we can find its position vector alpha bar. The vector equation of given line is, now see here, R bar is equal to A bar. What is A bar? A bar is the position vector of the point on the line. So here x1 is minus 1, y1 is 3, and z1 is minus 1. So R bar is equal to A bar plus lambda into B bar. Now A bar is minus I cap plus 3j cap minus k cap. This is your A bar. Plus lambda into B bar. What is B bar? B bar is the vector which is parallel to this line. The direction ratios of this line are 2, 3, minus 1. So B bar is 2i cap plus 3j cap minus k cap. Now this is the vector equation of line. Here A bar is this one and B bar is this one. So therefore A bar is equal to minus I cap plus 3j cap minus k cap, and B bar is equal to 2i cap plus 3j cap minus k cap. The point P is 2, minus 3, 1. So therefore alpha bar is equal to 2i cap minus 3j cap plus k cap. Now once we know alpha bar, A bar, so we can find the shortest distance or the perpendicular distance or the length of the perpendicular from the point 2, minus 3, 1 to this line. This is the line here. This is your given line and point is here, that is P, whose coordinates are 2, minus 3, 1. And so we have to find out this shortest distance. And formula is known. We know that shortest distance, that formula is square root of magnitude of alpha bar minus A bar bracket square minus alpha bar minus A bar dot B bar divided by magnitude of vector B bracket square. So first, to get the shortest distance we require alpha bar minus A bar. Now find out alpha bar minus A bar. It is equal to 2i cap minus 3j cap plus k cap minus A bar. What is A bar? Minus I cap plus 3j cap minus k cap. So take the subtraction of these two vectors. It is 2 minus minus become plus. It is 3i cap minus 3j cap and minus plus become minus 3j cap minus 3j cap minus 6j cap. Now this is k cap minus minus become plus k cap, that is 2k cap. So this is alpha bar minus A bar. This is alpha bar minus A bar. 3i cap minus 6j cap plus 2k cap. Now we have to find out its magnitude. So magnitude of alpha bar minus A bar is equal to square root of 3 square plus minus 6 square plus 2 square. So it is equal to square root of 3 square 9 plus 6 square minus 6 square 36 plus 2 square 4. So it is equal to square root of 49. Square root of 49. What is this? Alpha bar minus A bar. Also here we require alpha bar minus A bar. Alpha bar minus A bar. It's a dot with B bar. It's a dot with B bar. Now alpha bar minus A bar is 3i cap minus 6j cap plus 2k cap. It's a dot with B bar. What is B bar? 2i cap plus 3j cap minus k cap. So dot product of these two. It is equal to 3 into 2 plus minus 6 into 3 plus 2 into minus 1. See, 3 into 2 plus minus 6 into 3 plus 2 into minus 1. It is 6. 6 into minus 3 become minus 18. 2 into minus 1 become minus 2. So it is equal to 6 minus 18 minus 2 minus 20. 6 minus 20 minus 14. It is alpha bar minus A bar. Its dot with B bar. Now magnitude of vector B, it is equal to, see, vector B is there, 2i cap plus 3j cap minus k cap. So its magnitude is square root of 2 square plus 3 square plus minus 1 square. So it is equal to square root of 2 square 4, 3 square 9 and minus 1 square plus 1. So it is equal to square root of 14. Now the length of perpendicular from 2 minus 3 1 to the line, to the given line, is equal to square root of, see, alpha bar minus A bar, its magnitude bracket square, minus, in bracket, alpha bar minus A bar dot B bar. So alpha bar minus A bar dot B bar, that is minus 14. Minus 14 divided by magnitude of vector B, that is square root of 14. Its square. So again it is equal to square root of, first we write the formula and then put the values, that is alpha bar minus A bar, its dot with B bar, divided by magnitude of vector B bracket square, and in next step we will put the values. So it is square of alpha bar minus A bar, magnitude of alpha bar minus A bar square, that is square root of 49, and square root of 49 its square minus alpha bar minus A bar dot B bar, that is minus 14, divided by square root of 14 bracket square. So again it is equal to square root of, see, square root of 49 square, that square and square root get cancelled, it is 49 minus 14 divided by square root of 14. This minus 14 can be written as minus, that's minus sign as it is, and that 14 can be written as square root of 14 into square root of 14 divided by square root of 14 bracket square. Again it is equal to 14 square root of 49 minus 1 square root of 14, which 1 square root of 14 get cancelled. It is in bracket minus square root of 14 bracket square. Again it is equal to square root of 49 minus square of minus become plus, and this square and square root get cancelled, it is 14 only. So again it is equal to square root of 49 minus 14, 35. So this is the shortest distance or length of the perpendicular from the point 2 minus 3 1 to the given line. So it is distance, so I have to write it as units. So this is the solution. Now this problem can be solved by alternative method. So we see its alternative method. The problem is same. See, the point P is here, whose coordinates are 2 minus 3 1, and line is this one, whose equation is x plus 1 divided by 2 is equal to y minus 3 divided by 3 is equal to z plus 1 divided by minus 1. This is the shortest distance, this is the perpendicular distance of the point P from the line, and if this M is foot of the perpendicular, this M is foot of the perpendicular. Now, as the equation of line is in Cartesian form, the direction ratios of this line are 2, 3, minus 1. The direction ratios of that line are 2, 3, minus 1. Let a capital M be the foot of the perpendicular. The alternative method is this one. Let M be the foot of the perpendicular drawn from P, point P with coordinates 2, minus 3, 1 to the line x plus 1 divided by 2 is equal to y minus 3 divided by 3 is equal to z plus 1 divided by minus 1. Now here your x1 is minus 1, y1 is 3 and z1 is minus 1. The direction ratios ABC, A is equal to 2, B is equal to 3 and C is equal to minus 1. Now M is foot of the perpendicular, that point M lies on the line. The point M lies on the line. Now point M lies on the line. See, suppose if M is variable point, the coordinates of that point are not known to us. We have seen in one of the remark, the coordinates of variable point on the line x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c are x1 plus a lambda, comma y1 plus b lambda, comma z1 plus c lambda. So therefore the coordinates of M are x1 plus a lambda, y1 plus b lambda and z1 plus c lambda. That is, now put the values of x1, a, b, x1, y1, z1 and a, b, c. Here x1 is minus 1. So it is minus 1 plus a lambda. What is a here? 2. So it is 2 lambda. Comma. Y1, that is 3 plus b lambda. What is b here? 3. 3 plus 3 lambda. And C, Z1 is here minus 1. So third Z coordinate is minus 1 plus C lambda, but C is minus 1, so minus lambda. Minus 1 minus lambda. So these are the coordinates of point M. Coordinates of point M are, so minus 1 plus 2 lambda, that can be written as 2 lambda minus 1. 3 plus 3 lambda, this is 3 lambda plus 3. And this is minus lambda minus 1. Minus lambda minus 1. So these are the coordinates of point M. Now coordinates of point P are known. Coordinates of point M are here in the form of lambda, where that lambda is parameter. Now if PM is the segment or PM is the line segment on which 2 points are given, that is P and M, so direction ratios of PM can be found. The direction ratios of PM are, see, direction ratios of PM, we know that if we have any 2 points on the line x1, y1, z1 and x2, y2, z2, then the direction ratios of that line are x2 minus x1, comma y2 minus y1, comma z2 minus z1. Now consider x1, y1, z1 as the coordinates of point P and x2, y2, z2 as the coordinates of point M. So direction ratios are x2 minus x1, that is 2 lambda minus 1, this is x2 minus x1, that is minus 2, comma y2 minus y1, 3 lambda plus 3 minus, here y1 is minus 3, so minus of minus 3 plus 3, comma z2 minus z1, minus lambda minus 1, minus lambda minus 1 minus 1, so minus 1. See, z2 is minus lambda minus 1 and z1 is plus 1, so z2 minus z1 become minus lambda minus 1 minus 1, that is 2 lambda minus 3, 3 lambda plus 6 and minus lambda minus 2. Now these are the direction ratios of PM. Now PM is perpendicular to the line. PM is perpendicular to the line. The direction ratios of line that are given 2, 2, 3, minus 1. Direction ratios of line are 2, 3, minus 1. Now PM is perpendicular to the line. We know that if two lines are perpendicular to each other and if they have direction ratios A1, B1, C1 and another line has direction ratios A2, B2, C2, and if these two lines are perpendicular to each other, then we have A1, A2 plus B1, B2 plus C1, C2 is equal to 0. See, if we have two lines with direction ratios A1, B1, C1 and A2, B2, C2 and these two lines are perpendicular to each other, then we have A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Now here the PM is perpendicular to the line. The direction ratios of PM are known to us. Direction ratios of line are also given, that 2, 3, minus 1. So therefore we have 2 lambda minus 3 into 2 plus 3 lambda plus 6 into 3 plus minus lambda minus 2 into minus 1 is equal to 0. So therefore see, take the multiplication. 2 into 2 lambda, 4 lambda minus 6 plus 3 into 3 lambda, 9 lambda plus 3 into 6, 18 plus minus 1 into minus lambda plus lambda and minus 1 into minus 2 plus 2 is equal to 0. So again 4 lambda plus 9 lambda, 13 lambda, 13 lambda plus lambda, 14 lambda, minus 6, 18 plus 2, 18 plus 2, 20 and 20 minus 6 plus 14 is equal to 0. 14 lambda plus 14 is equal to 0. So 14 lambda is equal to minus 14. So lambda is equal to minus 1. Lambda is equal to minus 1. Now put this value of lambda in the coordinates of point M. So therefore coordinates of M are, see, coordinates of M are 2 lambda minus 1, 3 lambda plus 3 and minus lambda minus 1. Only put lambda is equal to minus 1 in this. So it is 2 into minus 1 minus 1, comma 3 lambda is 3 into minus 1 plus 3, and comma minus of minus lambda means minus of lambda, that is minus 1 minus 1. It is, that is 2 into minus 1 minus 2 minus 1, comma 3 into minus 1 minus 3 plus 3, comma minus of minus 1 plus 1 minus 1. So that is, the point M is minus 2 minus 1 minus 3 0 0. So point M is minus 3 0 0. Now we have to find out the distance between 2 points, that is PM, and that is the length of the perpendicular. So the length of perpendicular from P2 minus 3 1 to the given line is equal to length of PM, means distance between 2 points P and M, and so which is equal to the distance between these 2 points can be found by using the formula square root of x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. So now here point M is minus 3 0 0 and point P is 2 minus 3 1. So it is minus 3 minus 2 bracket square plus 0 minus of minus 3 plus 3 bracket square plus 0 minus 1 bracket square, that is equal to square root of, see, minus 3 minus 2 minus 5 bracket square plus 0 plus 3, that is 3 square, plus 0 minus 1, that is minus 1 square. So again it is equal to square root of minus 5 square 25 plus 3 square 9 plus minus 1 square 1, and that is 25 plus 9 34, and 34 plus 1 becomes 35. So it is square root of 35 units. See, this is the alternative method to find or to get the distance or length of the perpendicular drawn from given point to the given line. So there are two methods. Among these two methods, any one of them can be used. So today we stop it here. In the next lecture we see the examples on distance between parallel lines.